This isn't going to be a super technical talk, just in case anybody was hoping for that. There's a lot of good technical Go stuff on the internet written by the guys who write Go, so I suggest go there. This is a lot more centered around kind of, why transitioning from, say, Python to Go is rather easy and why you might find it helpful in some of your upcoming tasks that you might need. So the basics of Go. Go, for the most part, is expressive, concise, clean, and efficient. Writing the language is, rather nice to do. It's very close to something like Python or C, except it gives you some benefits depending on what you're kind of doing. It's statically typed, which can make things easier when having to deal with functions and stuff. I have trouble sometimes reading Python documentation and trying to figure out what actually gets returned from certain functions. Sometimes I have to dive into like the interpreter and test things out before I can actually figure out what's going on. It's also compiled. It compiles down to a single binary, which I'll talk about later. But while doing all this, it still kind of feels similar to something like Python. It feels kind of dynamic and interpreted, but it's not. It's newer, so they've been able to kind of pull in some of the things that have kind of annoyed developers over the years and pull them into the library. It has nice things like, a HTTP server library that you can run in production directly from the standard library. I don't know, most people don't use stock HTTP server in Python as far as I know. They tend to use something like Django or Flask to wrap around it, but you don't need that for the most part with the Go stuff. It's easy to build both CLI tools and APIs really quickly, which is nice to need, and it's also garbage collected. And it's not kind of a garbage collector like Java, and where you have to tune it and almost have a PhD in the garbage collector to get it to work right. It's pretty efficient for what it does. It can deal with hundreds of gigs of heap space, basically, and garbage collect it in the low tens of milliseconds, which is pretty nice to have and not have to deal with yourself. So here's a basic Hello World program. It's the most basic program you'll ever write in anything for the most part. I'm really just showing it here just so that you can see kind of the differences or kind of the similarities between Go and Python. You basically in Go, you start off by creating a package. If you're creating the main binary, the package is main. If you're creating a library, it can be something else. Then you do imports. Go doesn't automatically bring in things like a print statement, so you have to import the format library to do that. And then you create a main function, which is the function that gets executed when the binary gets executed. And in order to build this, you just simply run go build hello world, or whatever your file name is. Or you can use star.go if you have a bunch that will all be kind of compiled into a single binary. And then it produces the single binary, and then you just go ahead and execute it, and you're done. It's fairly simple. So the default toolchain for Go is rather nice. You get formatting by default. With something like Python, you have to install Pylint to get that. Go format, the Go FMT will do the formatting automatically for you in the file. The Go import side will do the same thing as Go format, but it'll also rewrite your imports to bring in any new libraries that you might have added but didn't actually import yet. It has the built-in testing functions for you. You don't need to necessarily install something like PyTest or Nose in order to get better test output. It will do race detection. Concurrency and parallelism is one of the big things about Go. And when you're building in dev and stuff, or dev and stage, you can build it with this race detector, and it will throw out into the logs when it sees two things trying to access something at the same time, so you can go in and fix that, which is helpful. It has more of like a static analysis type tools in Go Vet and Go Oracle. They'll look a bit deeper into the code and figure out if maybe you're doing something weird or maybe you missed something. I think in Go16, it can even like look at a print statement and tell if you wanted to use a variable or if you wanted to use another function as like the input to part of the print statement, which is pretty cool. It'll help you with refactoring. So it has the Go refactor. But kind of one of the glaring missing parts of this is that there's no official debugger currently. There's a couple third-party tools that you can use to do the debugging, but there's no actual, Go bless debugger out there, which can cause some problems when you have some particularly gnarly bugs that aren't necessarily easily found with print statements or the like. The standard library is pretty full-featured. Like I said, it has things like the HTTP server that's pretty much production ready for you. It can basically build an entire API or web service, just using that. It also it does a lot with concurrency and parallelism inside of the standard library, except where it can't really. So you don't want to use things like maps when you're doing concurrency as far as writing into them. I believe now in Go16 it'll actually panic for you and tell you not to do that, which is kind of interesting. They're also rather quick to update and add new features. Like HTTP 2, I think was standardized like a month before or something, the last Go16 release, and they already have it in there. So you get some good features into the standard library rather quickly, and you don't always have to rely on kind of the third-party tools to do that for you. But the third-party libraries, there is a good set, and it seems to constantly be growing. Currently, you pull in third-party libraries by just simply calling, or basically it's just another repository. It's not a package or anything like that. So for the most part, you'll just put in like a GitHub URL or a Bitbucket URL, and it will go out and get that for you and download it. It doesn't have a separate dependencies file like something like pip will require. So it will actually just look at all of your source code files, figure out all your dependencies for you that you don't already have, and then download them locally. There's no current easy way to do kind of pinning on versions, though. So the main way to do that right now is with vendoring of your third-party libraries, which I'll show later. And right now, there's no PyPI equivalent either. So the main way that you find new libraries is with something like Google and blog posts, unfortunately. There's no central place that you can go and type in oh, I heard of a library called this, and it will give you kind of a listing like PyPI might. So that can be a problem at times, but it's not too big of an issue, really. So a standard import statement might look like this. So at the top, we have two entries for from the standard library. And then this third one is just simply another repository on GitHub. And basically, it's github.com / and the user, and then the repository, and then you can even break it down farther into folders inside of the repository. And here I basically have 3. So what will happen is that when we download it, it will go off to github.com, and it will actually pull down these source control or these repositories locally onto your machine, and then go in a special directory, and Go will know where to go get those, and you can just use those however you need to. So to actually go get them, you use go get, which is pretty easy. It downloads them under an environment variable called gopath, and all of them are basically local to your own Go path. So if multiple people are using the same host and you all have different Go paths, you won't kind of contaminate the others if that's actually an issue. Usually isn't. But let's say that you might want to make sure that version changes don't break your dependencies and things like that. So you can do what's called vendoring. And basically, to set up a project, underneath your Go path, you can set up a project. Here it's called My Project. And then inside of there, you have your program files. And then inside of there, you also have a directory called vendor. And inside of there, you basically replicate your third-party dependencies that are under your Go path into there. So now these stay inside of your repository under your version control. So if the third-party library decides to change things and update things on their end, it won't break your actual code unless you update these files as well. Just simply running a go get on your system for this project will not update this vendor folder. There are some separate tools being built now that will automatically build out this vendoring file for you. It's currently not built into the Go toolchain, and I'm not sure if it's going to be in 1.7 or not. But there's a good number of tools out there that you can use to automatically do this and track revisions and things like that. And one of the nice things about this is that dependency management really is only the issue for the developer. With something like Python, if someone wants to run your scripts, they have to download the package and then install all of the dependencies to be able to run it. With Go, since we're building this single binary in the end, we don't, the users don't have to worry about having the dependencies actually on their system. And this makes installation for the users a lot easier. Error checking is rather simplified in Go. There's no exceptions or anything like that. There is panicking, but panicking should be used as a last resort. And there's basically a common construct of returning values, whatever values you want to return from a function, and then an error along with it. And then you just do a simple check. So in the Go code on the left, you call out to some function, you give it a couple values, and then you place the return values into two variables, and the second one is an error. And all you basically do here is you just check if it's not equal to nil, which is the none equivalent in Go. And if it is, you can do something and return from where you currently are, or you can try to fix the problem or do whatever, as opposed to kind of trying to catch exceptions and fixing things from there. From the documentation for Python, I have issues with finding what exceptions certain things pass, which can kind of be a problem. So, and I don't always like to just catch everything. So I kind of like the Go way a little bit easier, because it's easier just to kind of catch things and know that you're catching the right things, because really there's nothing to catch. I also like the documentation a lot more. I feel like it's easier to kind of understand. It's easier to go through. All of it's automatically generated, like a lot of it is on the Python side. One of the nice things about the documentation is that it's actually interactive. So if in the documentation they put an example, you can actually run it inside of the documentation. You can even edit it and change values and things like that. It won't do everything for you. You can't make like network calls and stuff like that with it. But you can kind of test out the basic functionality actually inside of the documentation, which can be really nice when you're trying to get something running. And all of the documentation is available in any installation of Go. If you run this go doc-http and then give it a port, it will actually spin up a local server that will give you the documentation for everything on your system, including the third-party libraries. And then you can just simply open that up in your web browser and be able to just kind of search through everything without having to go on the web or something. It's nice if you're on a plane or if you're just trying not to get distracted by other things that are on the internet. And here's a basic example of what it looks like. So it has the function name at the top, and then it gives you an example of what the function looks like, so you know, okay, I have to give it two things. I have to give it a net listener and a handler, and then it's going to return back to me an error, which is the last part. And then it gives you just kind of a simple description of what's actually happening there, which is rather easy to just kind of look at quickly and follow. I believe that the concurrency and parallelism is a bit easier in Go. You don't have to fork out child processes and do that sort of thing. There are lightweight threads called goroutines inside of Go, which are very easy to get started and running in the background. All you basically do is just use the keyword Go in front of a function name, and it will go off and it will just run that in the background. And if that has something like an infinite loop in it, it'll just sit there until you feed it something. Or it will just kind of execute what you want it to, and then once it's done, it's gone, and it'll be garbage collected, and the runtime doesn't care about it. It's relatively easy to run thousands of Go routines, tens of thousands. I think some places run millions at times. It really just depends on what your box, what the size of the host is. And by default, Go will actually use all of the cores on your system now. It used to default to 1, but now it will default to actually taking over all of them, unless you explicitly tell it not to. And the way that you do message passing with Go routines is with channels. And I have a very basic example here of how to do that. So in the output function is basically a worker. It's just going to sit in an infinite loop, and it's just going to wait for input. And if it doesn't get input, then it's going to sleep for a little bit. And that's all it really does. And if it gets input, then it's just going to print it out. And we're just doing something really basic here. It's just going to print out like an identifier and then the value that it got through the channel. And then in our main function, we create this channel, which is basically just going to send ints through it. It's what's called a buffered channel. So, sorry, I get this backwards. But basically, this channel is set up to not have any space in it, so it will block until the other side reads. So when you're trying to write, the right side will block until something comes and pulls it off, and then it can continue. I believe if it was buffered, then it would push enough values into the buffer until it fills up, and then it would block. But we don't really care about that here. And then these 2 Go calls right here just simply launch 2 workers for us in the background. We provide it the channel so that they can read it from, and then we just simply do a simple for loop, and we just simply pass all the values through that to the workers that are running in the background. And with very basic output, we just get something like this, and we can just see that the workers just kind of alternate as they're picking up things off of the queue and just printing them out. So it's pretty simple to be able to kind of create a worker pool and just kind of feed it work to do, and it will just go ahead and do that in the background for you as much as you need it to. So probably the main reason I kind of really like Go is the self-contained binary that it produces. With the compiler, you can catch stupid errors. I tend to misspell things at times, so it's nice when it's like, hey, I don't know what this variable is, and then you can just go fix that. The Go format stuff will do some of that, but the compiler will catch a little bit more. It also allows for cross-compilation. So if you're on, say, OS X and you're not doing any C stuff inside of Go, you can compile a binary for Linux and just copy that over and just run it. You don't actually have to build this on a Linux host to get a Linux binary unless you're using C. And it produces just a single binary that has no dependencies on the actual host. So it doesn't care about things like glibc. It doesn't care about OpenSSL. It doesn't care about really any of that stuff. And it's great for distribution. So I have an example here, kind of a hypothetical. Say you write a tool for an on-call rotation. Somebody maybe new is there. They get paged at 2 a.m. They get an error. They look at the runbook. The runbook says, hey, run this script. So they go to, say, run this Python script, and they figure out, oh, I don't have the dependencies installed. So then they go ahead and they run something like a pip install in their system, and let's say that they have an old version of a dependency for something, but they need a newer version, and they don't necessarily want to break their machine. So now they have to figure out that conflict. So they'll probably do something like a virtual environment, activate that, do another pip install, and hopefully it works this time. With Go, you wouldn't really have this problem. And one of the reasons is because you can just build your tools, put them in a known location such as S3, and just give the users a way to just download them and run them on their systems. So you actually have a way that you can kind of verify that the tools will function on the user's machine when they really need them, because you don't want to have to debug the script to actually fix your problem at 2 a.m. in the morning. You just want it to go off and work. And then this, has anybody here heard of PEX? Okay. So PEX is basically like a magic zip file for Python, so you can put all of your dependencies inside of it, and it will basically unpackage all of them and go off and run it. PEX are nice, but usually to do kind of simple PEX stuff, you need something like Pants, Bazel, or Buck kind of building your code, unless you're good at packages. It can also require some rewriting, because if you're you have to be able to read local to the package, and if you're not building that by default, it can be problems. So if you have maybe something like a default config file that it wants to read that gets packaged with it, you have to use the package utils library in order to actually read that, and not just simply do an open, because the locations get all weird inside of a PEX. And this helps you leave it. So let's say that you want to deploy some code with Go. It can be, all it really is a copy of the binary, a copy of the files that are needed. You can start it and then put it behind the load balancer. If it's something like a web app, for Python, you copy over the project files, you install the required dependencies, you copy over other files, you install something like Nginx or Unicorns in front of it. You then configure those, that Nginx and Unicorns, and then you finally start up the services, and then you place it behind the load balancer. So it can really kind of simplify the actual deploying of your code out into your environment, which makes things a lot easier, because you have less things that can possibly go wrong. And of course, containers can fix this. But with the Python runtime, you are creating larger containers. Some people pull in things like the Ubuntu or the Fedora-based containers, which can be hundreds of megabytes. And if you're pulling down 50 of the same container from a single Docker repository machine, that can put a lot of strain on that machine. And now all of a sudden you have really slow Docker pull times, which basically, when you first start a container, the time to start it isn't just running the Docker run command, it's running the pull and then the run. And with a Go binary, you can use the Scratch container. And all the Scratch container is basically just an empty file system. So you can drop the Go binary in there, and then the Docker container is just really the size of the Go binary, which is usually between 5 and 10 megabytes. So you can have these 5 or 10 megabyte containers, or you can have something that's maybe 50 to 200 megabytes, depending on what base image you have to use in order to get Python installed. And there's already a lot of cool things that use it. It really can scale and do things well. The Kubernetes project is all written in it. All the Docker CLI tools are written in it. And their backend stuff like the registry and Swarm. HashiCorp writes all their new stuff in it. I think Vagrant is their only thing that isn't written in Go now. etcd is another. There's a high-performance messaging queue called NATS that can do about 11 million messages a second in PubSub, which is cool. And then there's also just kind of simple, easy-to-use tools such as Hugo, which is a static site builder that you can easily go ahead and build static sites with a single binary that you can just drop on your machine and it runs. And that's it. If you have any questions outside of this, you can reach me at that, basically at anything, Gmail, whatever.